Wonderful speech. I think it's very inspiring just to think about bringing on 400 gigawatts of capacity in Europe alone. I think that challenge is one that we'd all like to take up and participate in. You know, the mood for the last year hasn't exactly been the mood that we've seen over the years before. We've had an economic downturn and change in policy that's affected photovoltaic deployment by about 25% on a worldwide basis this year. One of the things in my country, in the United States, we've seen is not only energy demand go down, but energy prices go down this year. And when that happens, it makes the message much more difficult to deliver on clean energy. Natural gas prices, of course, are at historic low levels, down 3x from the peak of just a few years ago. But certainly, all things are not bad. And certainly at this conference, you can sense the sense of optimism starting to bloom. People are talking about the future again as policies get put in place all over Europe, but also I think we can see them happening in many, many spots around the world. If we just kind of take a look at some of the things that might happen, certainly the thing that I like to hear about the most is a 12% paradigm shift, putting on 400 gigawatts in Europe. If that paradigm can be achieved and set, there's no reason why it can't be achieved all over the world. If we just look at some of the projections today, the first one from various industry associations, and I'm taking a number of these to average, the projections are about 100 gigawatts by 2020. I think that's quite a conservative estimate from what we've heard this morning. If you think about the United States, a year ago, not many in this audience would have had much hope for a major build-out of PV in the United States. Certainly, the outlook has improved during this last year. Energy bills are being introduced to the U.S. Congress. The climate bill was introduced this week by Senators Boxer and Kerry. So there is certainly hope that the United States will change path. The expectation here is that we most certainly will have an energy bill of some type passed and signed by President Obama sometime in the next 12 months. We believe that a renewable electricity standard will be in there, and that there'll also be a multiplier effect or an incentive for distributed generation, which will largely be PV. Our estimate here is that 2 to 3% of the electricity then, of the 15% or so that will be renewable energy, will be photovoltaics, resulting in something between 70 and 100 gigawatts of photovoltaic capacity in the United States by 2020. Certainly, this number is a relatively small number compared to what was just presented. If the United States was to reach that 12%, actually the number would be relatively similar, 400 gigawatts of capacity that could be distributed in the United States over this period of time. That's a gigantic amount, and of course, I think if you did the math and looked at what it would be on a worldwide basis, you'd see that if the world got to 12%, maybe not by 2020, but by between 2030 and 2050, it would be 2,000 gigawatts of deployed PV. Just a huge amount of scale in this industry. So I think in the United States, there is movement, a pretty dramatic movement. It may take some time. The workings in the United States have to go through Congress. So in the meetings that I've had with the President, we've tried to encourage him for the federal government to do something big in PV. In the past in the United States, there have been major projects to create electricity. The Hoover Dam is one that most international citizens are familiar with. That kind of demonstration project could really change the course of activities in the United States over a period of time. Of course, there's also necessary financing, because the cost here, actually one of the biggest costs, is the cost of money. And we've also been encouraging that there be a green bank in the United States to reduce those costs. But certainly the United States isn't the only place that has big potential. One of the places that has the biggest potential for deployment is China. We've recently heard of 20 gigawatts by 2020, but when you look at how much electricity China needs increased every year, it's almost a gigawatt a week of 24-hour kind of deployed capacity. So 20 gigawatts by 2020 is a relatively small amount of electricity in China relative to the need that will be created over the next 10 years. So the potential is high, and I believe the way you reach that potential is by driving down the cost and reaching scale, not only in China but around the world. So one of the things that I'm looking forward to is China not only being a major producer of solar panels and solar, but also to be a major consumer of solar electricity, one that allows all of us to participate in a growing market. As technologies grow and scale, there's generally a curve like this that they follow to ramp up in technology. And each one of these segments has different characteristics. In the first development phase, which I would say we're just kind of finishing in photovoltaics, there's a lot of investment, a lot of startup companies, new technologies come out, technologies get honed, they get into production, and that's pretty much what we've seen so far in photovoltaics. It's taken quite a bit longer than probably any of us expected it would take. Photovoltaic industry has been around a long time, been certainly in production for about 30 years. But only now, I think, are we reaching the point that we could say we're in a scale-up mode. And a scale-up mode has very different characteristics. A scale-up mode is not so much about technology, but it's about cost, volume, getting large-scale production deployed. It's about standards to drive down costs, material cost reduction. It's also, in this case, which is quite different than maybe some of the other cases that we talk about or examine, or in my case, our company's case, participated in. It's about reliability. We're talking about the production of electricity here. And certainly, while some of you know where your electrons come from, you can't differentiate between the electrons that you get from clean energy and those electrons you get from fossil fuel generated energy. And that makes it quite a bit different. And so reliable production is very, very important. Reliable products are very, very important. And as we go through the scale-up, which I've kind of looked at this next 10-year phase, if we just think about the projections that we've seen between where we are today at 15 gigawatts deployed to the over 100 gigawatts deployed, that 10x change now is the scale-up period. And this scale-up period is incredibly important for us, because by the end of this scale-up period, we really do have to be out of the incentive game. We have to not only reach parity with the retail prices, we have to reach parity with wholesale or true generating cost prices.